In this electric circuit, we know the voltage. We have 3 resistors. These two are in parallel. Let's find out the equivalent resistance in here right away. I'm going to call it R2 prime. So 1 over R2 prime equals to 1 over R2 plus 1 over R3. That's how we find out the equivalent resistance in parallel parts. So that will be 1 over 20 plus 1 over 30. That's going to give us 60, 3 plus 2, 5 over 60. So RT prime is going to be 60 divided by 5, which is 12. Oh, that's going to be 12. Then we have in series this one and this one. So RT will be 12 plus 6 is going to be 18. Oh. Then I can say IT or I naught equals to V naught divided by RT, which is 9 divided by 18, and that's going to be 0.5 ampere. So I naught is 0.5 amp. So I1 is going to be the same as I naught, which is going to be 0.5, but in here is going to be distributed in these two. So let's find out V1. V1 equals to I1 times R1. I1 is 0.5, R1 is 6, so it's going to be 3 volts. So 9 volts, 3 of them is going to be lost in here. So we're going to have just remaining 6 volts. There is no other resistance in here, so it's going to lost in here. And for 2 different branches in parallel, we're going to have the same voltage. So it's going to be 6 here and 6 here. So V2 equals to V3 equals to 6 volts. And after that, we can find I2 and I3. I2 is going to be V2 divided by R2. I3 equals to V3 divided by R3. V2 is 6 divided by R2 is 20. And here we have 6 divided by 30. This one is going to be 0.2. This one is going to be 0.3. I2 is going to be 0.3. I3 is going to be 0.2 amp and amp. That is obvious because this one has lower resistance, so this branch must have higher current comparing to this one. And since ampere, before this branching, it was 0.5. So when you have 0.5, it is going to distribute it proportionally. So it means that 0.3 in here, 0.2 in here. That's how we find out the voltage, resistance, and electric current for all the resistors.